Assalamualaikum and good day, student. Welcome again. This is the continuity of friction clutches, video number 2. We will look into the what is the friction force exists in a single plate clutch. Assuming there is two disc plate over here on the left hand side and on the right hand side. So this is the flywheel from the engine, let's say, with a rotational speed at a predetermined rotational speed at a certain angular speed, let's say, and then with the input power of let's say in a few kilowatt, and then on the black side, on the black color over here is the friction plate to the gearbox. And then we notice that there is a friction plate with a predetermined radius from the center of rotation over here. This one is R2, and then to the edge of the black color over here is R1. And then the friction plate, known the coefficient of friction as mu. By the time we give certain axial pressure to the another shaft on the right hand side, or we give a axial thrust force moving to the left, so both this will engage, which means that both this will rotate at a certain rotation, at the same rotational speed compared to the input side. At the same time, when the both of the disc is rotating, of course there is a frictional force exists between the two discs over here, because friction force is opposite direction of the movement. So we will talk about the torque generated. How much is the torque generated from this engagement? Let's say this is the point. I just pick one point over here at the friction plate over here, and then this is the mean radius from the point that I pick to the center of rotation over here, mean radius. So torque generated by the friction force over here is actually friction force times mean radius of the friction surface. So in a simple formulation is torque equal to F times R. We will look into the derivation on how to derive torque equation at friction plate. Let's say this is the gray color is a friction plate with a radius of R2 over here, and then this is R1, and then we just take a small amount of area over here, which is known as the radius is known as R, and then the thickness is dr. So what we do, I try to enlarge a small portion over here. So this one is actually the thickness of the friction plate, dr, and then the plate is rotating to the left hand side, and then this is the axial force, the small amount of axial force, dFA. Since the disc is rotating to the left hand side, so there is a small amount of friction force acting to the right hand side. So from here we know that from the basic equation, P is equal to F over A, and then the friction force exists is actually mu n, the normal force. So mu actually is N is the the normal force is actually the axial force. From the small amount of this area, so we arrange the equation until become like this. So redefine the equation, and then followed by this equation. So FA is actually a small amount of FA, dFA, and then this is the dFA. We just replace from this equation, so we get another equation. Okay, before we proceed to derive a torque equation on the friction plate, we need to know there is a two assumption we need to there is a two assumption that we need to consider on the friction plate condition itself. So the first condition is, if you look at this graph, actually, let's say this is the time we install a plate. So by the time we install the plate, this is the new clutch. So all the surface of the friction plate is a brand new. There is no wear and tear and so on. So maximum, this is torque actually. So maximum torque is available over here. So the plate is still in a good condition. So this is in the condition of uniform pressure. Whereas on the uniform wear, so over the time, the friction plate will continue to worn off at a certain area over here. So after years of operation, the friction plate will continue to having a wear and tear. This is the assumption of uniform pressure, a new plate. We assume that all the point over here is having a uniform pressure. So to simplify, this is the equation of torque that capable by the friction plate to be transferred or to be generated. This is the torque that can be generated by the brand new or uniform pressure plate, compared to the if we are assuming the worn-off plate or uniform wear. So this is the equation. So in uniform wear condition, the maximum pressure is received by this radius, which is R2. Maximum pressure is being received by at this area P max, which is considered as R2. Okay, now how to derive torque equation by uniform pressure assumption, which is a brand new clutches. From the previous equation, this is P equal to FA, and then rearrange back the equation from torque equation. So you know that torque is equal to F friction force times R, the radius of that one. So a small amount of torque, dFr times R, and then this one you put here from the previous equation. Then rearrange the equation, you do the integration of that one from R2 to R1, and then by the time you do the integration, you will get this equation. This is equation number 4, this is equation number 3. So you just put equation number 3 to equation number 4, you will get this some sort of like, this is a new equation over here. Simplify the equation until you get this simplified equation. So this one proves the previous equation that we get on the uniform pressure equation for torque that been capable to be transmitted by the brand new clutches. Okay, this is the equation. To simplify this equation, actually torque equal to mu times Fa times R, where R is the mean radius. So meaning that the red box over here is representing the mean radius of the clutches. So this is the equation of the torque that been capable to be transmitted by the brand new friction clutch. R is representing the mean radius. Okay, now we see on the uniform wear assumption. As you know that P max is exists at the R2 over here. This is R2. So to say that actually the pressure on the R2 is not the same as P. So it's not. This is okay. So we have to get the C, the value of C. We just put a value of C over here. So actually C is equal to CPR equal to CP times R, and then from 1 just now, from equation number 1, we know that this is the one, and then having a long derivation, and we will get the simplified equation over here. So this one, okay, this is actually the torque that been capable to be transmitted by the friction plate in a uniform wear assumption. So again, on the uniform wear assumption, the mean radius is actually on the red box over here. So it's different compared to the uniform pressure assumption. So this is the one of friction plate. Okay, let's see the difference in terms of uniform pressure equation and uniform wear equation. So you have to remember this equation compared to this uniform wear equation. So to simplify, to make it easy, so this is the mean radius for the uniform pressure, and then this is the mean radius for the uniform wear assumption. Okay, now we look into the multiple plate clutch. Just now we are discussing only on the single plate clutch. Now what about the multiple plate clutch? N is a number of contact surfaces. Number of contact surfaces is actually equal to number of driver disc plus N2, number of driven disc minus 1. Okay, now this is number of contact surfaces is equal to N1 plus N2 minus 1. What do you understand from this number of contact surfaces? If you look into this friction plate over here, there is two effective contact surfaces, which is on this side and on the another side over here. So this is effective surface number 1, and then the other side is number 2. Same applied to here. This one is number 3, and one is number 4, the effective contact surfaces. And then the last one is 5, and the other one on the behind one is 6. So if I'm looking into this multiple friction plate, multiple plate clutch, there is a 6 number of contact surfaces available. So the equation of the, like say I'm taking the equation of uniform pressure equation. So I have to times the number of contact surfaces of the friction plate. In this case, N is 6, so I have to times 6 over here from the using the previous torque equation on the single plate torque equation. So for the multiple plate clutch equation, you need to remember to times the number of contact surfaces, which is n over here. So that's all. Thank you. Till we meet again on the next video.